Shooters, reloaders, and conversationalists, welcome to Pounder Labs. Today we dive into understanding canelores. The word canelore is of French and Latin origin for channel. In modern spelling, the H has been dropped. All grooves or channels around bullets and cases are canelores. They could be a smooth bevel, a smooth square or rounded channel, or a knurled annular ring, usually straight. You might sometime hear this referred to as fluting, but in the shooting sports, we think of fluting in barrels and bolts, so we won't use that term here. A key idea to remember is that canelores are all about binding and or friction control. On bullets, you can have crimp grooves at the case mouth. Here's a knurled one. Here's a beveled one. You could also have crimp grooves in the body or the bearing surface, like shown here. You can also have what's called relief grooves. We'll get into that more in a moment. Also, there are lubrication or grease grooves, which can also double as relief. On cartridge cases, you'll have crimp grooves like shown here, or stop grooves. When you think about how these are measured, on the bullet, it's measured from the bottom, and from the case, it's measured from the top. If you think about how a bullet's inserted to a case, this makes sense. There's a couple of options for crimping with centerfire rifle. Might not have a crimp at all or a taper crimp, or you might have a roll crimp used in one or two ways. For rifles that shoot pistol caliber carbines and the rounds sit in a tube magazine, nose to tail, you certainly want to have roll crimps there. But also if the cartridge, like seen with this 50 BMG here, headspace is off the shoulder or the rim or a belt, you're able to roll crimp that, which might be useful in high stress, high demand type environments. In terms of canelores and bullet manufacturing, you might find it in terms of binding the core to the jacket, but also it's be used for friction or pressure control and fouling control, what we call relief. Look at this diagram here from cutting edge bullets, for example. You can see in the cross section here in A and also down in section C, these are what they call material displacement grooves. So these are relief grooves, the less material come through, because on a lot of target bullets that are long for caliper and monometals, which because the density is lower than lead will be long, they have to be designed for some relief of having friction control there. Another thing that comes up from time to time is just what we call a processing artifact. A bullet might be manufactured, it has a canelore on it because it's used on the same equipment for bullets that don't. So you'll see up here we have a canelore on the 50 BMG ball, but you can see this bullet isn't seated that deep into there. So when we look at using bullets in reloading, the canelores can be used for seating depth guidelines to kind of make sure that the rounds will fit within magazines and also maximum shooting depths. You also see it used for crimp zone. Here's some 22 calibers. You'll see a soft tip, full metal jacket, and you'll also see a long for caliber 75 grain here, which would be seated down to this point to make sure you have magazine length, and you also have the ability to crimp it. So you see everything from 700 grain M2 armor piercing all the way down to 22 caliber. You can see that canelores play a role in the use in bullets. On cases, you very seldom see canelores. There doesn't seem to be much of a commercial application. When we get to military applications with 100-year plus of military ammo, who knows what you would find for crimping there, but that's beyond the scope of our presentation. Crimping is very important for pistol bullets. We use the taper crimp for rounds that headspace off the case mouth. The taper crimp doesn't bite into the bullet. It's there to reduce any belling or flaring from reloading and to provide a uniform pressure around the bullet. Roll crimping, on the other hand, are for cartridges that don't head space off of the mouth. They face off the rim. And you can see from the diagram here, you shouldn't roll crimp bullets that don't have a crimp groove. In bullet manufacturing, cantilures usually aren't needed or used. You might run across cases where the binding of the jacket to the core might be used, and as we mentioned before, you might run across a processing artifact. Using the bullets in reloading, the roll crimp is used for high velocity rounds, and these are often knurled type on full metal jacket or plated bullets. For cast bullets, it's very common to use a roll crimp in the crimp groove. And for swaged bullets, you'll see either a smooth or a knurled type. In addition, you'll see lubrication grooves. You might also see a cantilever for gas checks. Let's look at some examples. This is a 95 grain and 100 grain. You'll see the small little cantilevers here. This is often put on a series of rounds that are designed for tumble lube. So instead of a large grease lube, you'll have these small cantilevers for holding the tumble lube. Here's full metal jacket and plated bullets of the 115 grain category. And then here's some for using 9mm. You'll see a grease groove here. You'll also notice on both these truncated flat nose, this one has a grease groove, and this is part of a newer generation that doesn't have that. So this is designed for tumbling lubes like Hi-Tech, but you can also have that apply on this sort of bullet, and you don't need to use that groove. Here's a couple of examples of the wad cutter bullets, about 148 grain like we would use in 38 Special. Here's the double-ended wad cutter with 2 crimp grooves and a lubrication groove. Here's one with 3 cantilevers of a knurled type. And here's the Hornady, where they use a diamond type knurl on it for holding the lubricant. Here's several that 158 grain. This will be plated with a knurled cantilever here. This is a swaged 158 grain with a smooth crimp and also a knurled here for lubrication. And then here's a 200 grain that you could have both a option for traditional lube or else also you can have it coated. These are for 44 Magnum. Here's a 240 grain with a bevel crimp groove and a lubrication groove. This is cast. And then here's a 200 grain. You'll see there's a couple of lubrication grooves as well as a crimp groove. These are several of the 452 mil category for 45 ACP. The traditional semi-wad cutter with a lubrication groove here. This is a 200 grain round nose flat point. You'll see both a crimp groove and a lubrication groove. Now in this one, you could use this for long colt and roll crimp, or else you could also seat it in 45 ACP and not use the crimp. And last but not least, here's a 230 grain truncated flat nose with a traditional square lubrication groove, which again is not used because we're tumble coating. As we get into centerfire handgun cases, things start to get interesting. There's 2 important safety elements. One is we need to prevent setback. This is where a bullet is set back further in the case, reducing case volume and creating higher pressure. Second is crimp jump or bullet jump. This is where the bullet comes out of the case, creating less pressure and a higher case volume. Both of these things have to be carefully thought about. You might also see cantilevers used for the retention for pressure build. Kind of think about it this way. As you provide a constriction in the case and into the bullet, pressure builds and get a more dramatic pop. Also, the cantilevers might be seen on cases there for identification, or it's an artifact, or even just a marketing image. It just simply makes the case look more dramatic. Cantilores are very caliber and application specific, but we can break it down into two general categories: defensive and hunting rounds and target rounds. We can further break this down into pistols and revolvers. On pistols, we have feed shock can create setback. If you think about the round being stripped from the magazine, slaps into the feed ramp, rattles up into the chamber, and slams into battery. So you can end up seeing both setback, and you also might run across crimp jump. Here's an example, a very dramatic case of setback with a 9mm round. It's also possible for heavy recoil and light guns, like defensive guns. You could also run across crimp jump there as well. In revolvers, usually heavy recoil can generate crimp jump. Here's a 44 Magnum, and you see it's jumped the crimp here. This could be quite significant, where if the projections increase so much, it can lock up the rotation of the cylinder, and that's another safety factor. Setback isn't that common in revolver applications. Cantilores are commonly used in high-power defensive ammunition, almost universally to prevent setback. Here's several examples. Plus P 9mm. Here's a selection of Corbon 380, several of their 9mm line, and you'll also notice here 45 ACP, all with stop cantilores. Notice the 45 here has a huge cavity, and since it's monometal, it needs a lot more material seated into the case, all the way down to the cantilore here. Clearly a situation you don't want any setback in this case. Cantilores are much less common in target ammunition. They'll see some setback stops like these 45 ACPs here, but we ask the question, should there be some cantilores used for pressure control? In high-powered revolver cartridges, cantilores are common. 44 Magnum, 454 Casull, and we have 357, both Winchester and Remingtons, and in all these you see stop cantilores. The use of cantilores in target ammunition is a little bit more involved. In the case here, the 32 Smith & Wesson long wad cutter, and it's compared to the 32 ACP. Notice the stop cantilores way down here. There's not much case volume to mess with, and you certainly don't want setback. Here's a set of the Remington, Winchester, and Federal target rounds for the 148 grain hollow base wad cutters. You'll notice that there are both stop cantilores as well as friction or constriction cantilores. These cases are often sought after by precision shooting, believing that it's maybe the case material or the case taper or something that's very special. Our proposal is the difference is really the cantilores and how they're used. There was one more topic we wanted to touch on, and that's using rimmed cartridges in pistols. We can again break this down between defensive and target applications. The Desert Eagle pistol is available in both 357 and 44 Magnum, and then the Kunin 1911 357 shot the 357 Magnum, and that was available both standard and compact length. Regrettably, these guns aren't manufactured any longer. On the target side, particularly for precision shooting like the NRA Bullseye, there's a family of high performance center fire pistols. For example, here is the Pardini HP, and these can be had with 32 ACP or the 32 Smith & Wesson long wad cutter like we showed on the previous slide. Both Colt and Smith & Wesson made pistols shooting the 38 special wad cutter, the Colt National Match 38 mid-range, and the Smith & Wesson Model 52 38 Master were both superb guns that are no longer manufactured. Adding cantilures to rifle and pistol bullets and pistol cases is very straightforward. We use and recommend the Ultimate Cantilure Tool, UCT. Shown here is their newest one, the Model 2. We view this as a research grade tool. However, for the hobbyist, this is a lifetime purchase, and the durability of the UCT easily makes it adaptable for production environments. We'd like to touch on a couple of things. The accuracy is very good because there's a large window here and very fine threads for making all the adjustments. And then once you lock all of the movement down, you can precisely reproduce that knurl over and over. Also, with the way it's designed and the handle, you get a very high embossing force for any applications. In terms of flexibility, bullets and rimless cases can be handled up to 2.5 inches. So this will cover long for caliber like target rounds, and also what we see for long bullets, heavy bullets like we see for the 300 Blackout are easily accommodated in the Model 2. The knurled embosser is easily replaced, and there's optional rollers for handled rim cases, and they also offer an optional diamond knurling tool for using on bullets with tumble loops. Let's focus in on a few examples where we're using the Ultimate Cantilure tool for our projects. For rifle bullets, you can easily duplicate the factory offerings. You'll notice here for some 22 caliber, here we have a Hornady E75 grain bowtail hollow point match, and we wanted to add cantilures to a Berger 82 grain long range bowtail target. In this case, we wanted to mark out, so we study constant case volumes with increased bullet weight. Over here, we have Lapua 140 grain bowtail hollow points for the 6.5 Creedmoor. We want to put the cantilure here because we know what our setback is from the rifling, and we want to have an accurate reference point to load all the ammo and easily see that it's holding that position. Here's the 38 Special 148 grain hollow base wad cutter. This is the Hornady swaged bullet, and that's already had dry lube on it. And we added two knurled type constriction cantilures here, and you can see we can line this line the case with the bullet to get a matching cantilure on this. Over here is the a 9mm 120 grain truncated flat nose. This is the Lee mold that was cast with wheel weights, and we've added a constriction cantilure here and tumble it with the our Recluse 45 tumble lube, and again we can easily align the case cantilure with the bullet. Is it advisable to remove the case cantilures in reloading? It depends. Often the chamber pressures will flatten out cantilures, but if not, and you don't have any constriction in seating, it's probably not a big deal. However, if you're seating wad cutters and you're concerned about performance, you have to think about these cantilures. To reduce and remove cantilures, we use the case ironing tool shown here. And here's the tool mounted in the Lee Advanced Processing Press. We also want to study seating force treatments, part of the things we look at with tribology on bullet seating. But another important use of the tool is identifying internal taper interference. For example, you can see the bulge here, and if you push the hollow base wad cutter down there, that would interfere or constrict the skirt. So we find that this particular vendor, they always have that taper coming up too high. So that's something you want to be aware of if you're going to load wad cutter ammo. We didn't forget about rimfire. Cantilures in rimfire are important. We just think it deserves its own discussion. Other things to look for is a demonstration video on the Model 2 of the Ultimate Cantilever tool, a video where we prepare and apply the Recluse 45 bullet lube, and then we'll be presenting some of the test results for ammunition that's been improved with cantilures. We know this is kind of a confusing topic, and hopefully we've helped clear that up a little bit. This completes our presentation today, and as you're thinking about subscribing, please look over these important notes and disclaimers. They're here for your protection and ours. Thanks for watching. See you soon.